Dear students, here properties of triangles. Exercise 10a. Problems on application of trigonometry. Problems on applications on trigonometry. Here there are 6 problems are there in applications of trigonometry in exercise 10a. So 13, 14, 15, 16, 17, 18. Only 6 problems are there in applications of trigonometry. So in this 15th problem, what is 15th problem here? A tree stands vertically on the slant of the hill from a point A on the ground 35 meters down the hill from the base of the tree. The angle of elevation of the top of the tree is 60 degrees. If the angle of elevation of the foot of the tree from A is 50 degrees, then find the height of the tree. So, here you observe, this is the observation point A. This is foot of the hill. BC is the hill and this is the ABC. A is the point of observer, BC is the hill and slant height of the hill AC. On slant height, one tree is there vertically. The PQ is the tree on slant height of the hill, and from the point of observing top of the tree, angle of elevation 60 degrees, and bottom of the tree, angle of elevation 15 degrees. This is QM, point on foot of the hill. Okay, before going to discuss about the figure, first we have to write the steps. What are the steps here? First one, a tree stands on vertical on the slant of the hill. That means height of the tree. So PQ is a tree standing on slant height of the hill. So height of the tree PQ is equal to H. Height of the tree PQ is equal to H. So in triangle AQM, here two triangles are formed. Two triangles are one is triangle AQM and other is triangle APM. Okay, all of you. In this, BC is the height of the BC is the hill. BC is the hill, and AQ is equal to 35 meters. AQ is equal to 30 meters. But what is AQ? A slant height. A slant height from A to bottom of tree. This is the slant height from observer point to the bottom of the tree. So in triangle AQM, in triangle AQM, you take triangle AQM. So angle QAM is equal to 15 degrees. Sorry, this is 15 degrees given. The bottom of the tree elevation is 15 degrees, and angle AMQ is equal to 90 degrees, right angle. Then we have to find angle AQM is equal to how much? That is angle QAM plus angle AMQ plus angle AQM is equal to 180 degrees. QAM is equal to 15 degrees given. This is 90 degrees plus angle AQM is equal to 180 degrees. Angle AQM is equal to 180 degrees minus of 105 degrees. 15 degrees plus 90 degrees, 105 degrees. You can take into this side. 180 degrees minus 105 degrees is equal to 75 degrees. So this angle is 75 degrees. And one more thing, angle PQA plus angle AQM. So angle PQA plus angle AQM is equal to 180 degrees. Straight angle. What is this? Straight angle, this one. So straight angle. Then we want to here PQA angle. So angle PQA plus angle AQM is what? AQM is 75 degrees. Already we get 75 degrees. So this is 75 degrees is equal to 180 degrees. 180 degrees. Angle PAQ is equal to angle PQA. Angle PQA is equal to 180 degrees minus 75 degrees is equal to 105 degrees. This angle is 105 degrees. So now we want here angle PAQ. Angle PAQ is equal to angle PAM plus angle PAM. Angle PAQ is equal to angle PAM minus angle QAM minus angle PAM is equal to angle QAM. Angle PAM. Angle PAQ. Angle PAQ is equal to angle PAM minus angle QAM. So angle PAQ is equal to 60 degrees minus 15 degrees is equal to 45 degrees. So this angle is 45 degrees. This angle is how much? 45 degrees. And also this angle is there. We have to find this angle. So what is that? In triangle A P M. APM. APM. Okay, all of you. In triangle APM, angle APM, angle APM or APQ, APQ plus angle APQ, angle APQ. So angle APQ plus angle PQA plus angle PAQ, PAQ is equal to 180 degrees. So angle APQ is equal to what? APQ we have to find angle APQ plus angle PQA, PQA, this is 105 degrees plus angle PAQ, PAQ, this is 45 degrees is equal to 180 degrees. Angle APQ is equal to 180 degrees minus 150 degrees is equal to 30 degrees. Observe here, this is the 30 degrees. Okay, all of you. So we have the triangle. We have the triangle. You write this triangle separately. This triangle. This is the PQ, and this is the point of observation, and this is the point A, and this is the slant height 35 meters, and this angle is 30 degrees. We already find this, and this angle is 45 degrees, and this angle is 105 degrees. Okay, this is the triangle we have. You see, all of you, from this triangle you apply the sine rule. From triangle this one APQ, this is APQ. From triangle APQ, apply sine rule. Here we have to apply sine rule. So here AQ, first one AQ by opposite sine angle. AQ opposite sine angle, sine 30 degrees. Sine 30 degrees equal to PQ opposite angle 45 degrees. So PQ by opposite sine angle, sine 45 degrees. But here we know AQ is equal to 35 meters slant height, and PQ is equal to height of the tree h meters. So AQ is equal to 35 by sine 30 degrees is equal to PQ h by sine 45 degrees. This is implies h is equal to 35 into sine 45 degrees by sine 30 degrees. H is equal to 35 into sine 45 degrees 1 by root 2 by sine 30 degrees 1 by 2. This is 35 into 1 by root 2 into 2. So H is equal to 35 into 2 can be written as root 2 whole square by root 2. Root 2 cancel. 35 root 2 meters. Therefore, height of the tree 35 root 2 meters. This is the conclusion of the problem. Okay, all of you. Dear students, here properties of triangles exercise 10a, 16th problem. 16th problem, applications of trigonometry, 16th problem, long answer question. What is the problem here? The upper 3 by 4th portion of a vertical pole subtends an angle tan inverse 3 by 5 at a point in the horizontal plane through its foot and at a distance 40 meters from foot. Given that the vertical pole is at a height less than 100 meters from the ground, find its height. Once again, I read the problem. The upper 3 by 4th portion of a vertical pole subtends an angle tan inverse 3 by 5 at a point in the horizontal plane through its foot and at a distance 40 meters from foot. Given that the vertical pole is at a height less than 100 meters from the ground, find its height. We have to draw the diagram from this given data. So, what is first given? One pole is given. Pole is, this is, let us this PQ. PQ is the pole and point A is observer point and height of the pole H. So, this is the observer point and this is the point of M. Okay, this is 3 by 4th of the pole. This is 1 by 4th of the H. This angle is subtend angle theta. This angle is alpha. This total angle is beta. Okay, all of you. PQ is the pole. A is the observer point. So, 3 by 4th of the pole subtend an angle theta and remaining 1 by 4th of the pole angle of elevation is alpha. Total angle is beta. So, given that you have to write the steps. So, 3 by 4th of the pole subtends an angle tan inverse 3 by 5. So what? This is theta is equal to tan inverse 3 by 5 implies tan theta is equal to 3 by 5. And let alpha is the angle of elevation of the 1 by 4th part of pole and height of the pole is PQ is equal to H. So, height of the pole is PQ is equal to H. Here tan theta is equal to 3 by 5 and tan alpha is equal to what? Tan alpha is equal to MQ by, this is AQ. MQ is equal to what? 1 by 4H by AQ is given. AQ is equal to 40 meters from foot of the pole to observer point. So here you write AQ is equal to distance between foot of the pole to observer. So tan alpha is equal to m cube by a cube 1 by 4 h by this is 40 equal to h by 4 into 40 is equal to h by 160. Tan alpha is equal to, and also from figure beta is equal to what? Theta plus alpha. So what is tan beta? Tan beta is equal to PQ by this is AQ, implies tan beta is equal to what is PQ? H. But what is AQ? 40. This is the tan beta. This is the tan alpha. Tan alpha is equal to h by 160. This is tan theta 3 by 5. Then from this triangle beta is equal to theta plus alpha. Tan beta is equal to tan of theta plus alpha. So tan beta is equal to, we have write as tan of a plus b form, that is tan theta plus tan alpha by 1 minus tan theta into tan alpha. So by cross multiplication tan beta of 1 minus tan theta into tan alpha equal to tan theta plus tan alpha. Okay, all of you. Then you have to substitute the values here. What is tan beta here? H by 40. H by 40 of 1 minus, what is tan theta here? 3 by 5. 3 by 5 into what is tan alpha here? H by 160. 160 is equal to tan theta 3 by 5. Tan theta 3 by 5 plus tan alpha h by 160. Okay, all of you. H by 140 of 1 minus 3 by 5 into h by 160 equal to 3 by 5 plus h by 160. You have to sub. What is here? We have, this is implies h by 40 of 1 minus 3 by 5 into h by 160 is equal to, this is 3 by 5 plus h by 160. So this is implies h by 40 of, here LCM, 5 into 160, 800. So this is 800 minus 3h equal to, so 5 zeros 0, 5 6 30, 0 3, 800. So 3 into 160, 0, 3 6 18, 1, 3 1 3 plus 1, 480 plus 5h, 800 cancel. This is implies by cross multiplication, this is 800h minus 3h square equal to 40 into 480 plus 5h. This is implies 800h minus 3h square equal to, so 4 8 32 3, 4 4 16, 16 plus 3 19, 19 0 0 plus 4 5 20, 200h. Here 800h, 3h square taken to this side, 3h square plus 200h minus 800h plus 200 is equal to 0. So this is implies 3h square, this is minus 600h plus 200 equal to 0. You take common 3 here, h square minus 200h plus this is 3 6 18, 18 1, 3 4 12, 0 0 equal to 0. This 3 will be cancelled. Then what we will have? This is implies h square minus 200h plus 6400 equal to 0. This is the quadratic equation in h. You solve for this. 6400. This is 160 into 40. You observe here 4 6 24, 2, 4 1 4 plus 2, 4 6400. So 160 into 40. That this is implies h square minus 160h minus 40h plus 6400 equal to 0. From this h common, h minus 160 minus 40 common, h minus 160 equal to 0. h minus 160 equal to 0 and h minus 40 equal to 0. h is equal to 160 or h is equal to 40. And we have the given height of the pole, vertical pole is at a height less than 100. Given that pole is less than 100 meters. So height of the pole is h is equal to 40 meters is the right answer. Okay, all of you. This is the conclusion of the problem. That's all.